Hola mga bata!
This is Ma'am Harding.
I'm Ma'am Fiancé and Ma'am Erica. Before we proceed to our topic for today, can you say Pythagorean theorem?
Pythagorean Theorem!
That's right!
In today's lesson, we will explain Pythagoras' contribution to mathematics, apply the Pythagorean theorem to determine a missing side of a right-angled triangle, and identify situations where the Pythagorean theorem could be applied in real life. Are you ready? Let's get started!
Today, I want you to meet a friend named Pythagoras. Say, Hola Pythagoras! Hola Pythagoras! He lived a long time ago in ancient Greece, approximately between 570 and 495 BC. That's way before you and I ever existed. Pythagoras was super smart and made really important discoveries in math. His most famous discovery is something called the Pythagorean theorem. So remember the name Pythagoras. He was a very important mathematician from ancient Greece. So let's explore Pythagorean theorem. This theorem is like a super secret code to find a missing piece in special triangles called right-angled triangles. See that triangle? It has a special corner, a right angle measured 90 degrees, marked with a little square. The sides of the triangle are labeled sides A, B, and C. The longest side, C, is called hypotenuse. It's always the opposite of the right angle. The Pythagorean theorem says a squared plus b squared is equals to c squared. Or we can also say that c is equals to the square root of a squared plus b squared. This means that if you square the length of sides A and B and add them together, you get the square of the length of the side C. It's like a magic formula to find any missing side if we know the other two. Let's say we know sides B and C. We need to find A. We only need to square root c squared minus b squared and we can find side A. Same as we want to know the missing side B. If we know the sides C and A, we only need to square root c squared minus a squared and we can get the length of the side B. It's like solving puzzle. So the Pythagorean theorem helps us find hidden treasures or the missing sides in right-angled triangles. Vamonos!
So how can we prove that? So here's a proof on how it works. Did you see the figure beside me? Okay! The image demonstrates a geometric proof of Pythagorean theorem, explaining how the diagram visually represents the theorem, and how the equation 3 squared plus 4 squared is equals to 5 squared. So, here's a short clip for you to understand. So, we already know that a squared plus b squared is equals to c squared. To emphasize, it is a times a plus b times b equals c times c. In this case, 1 square or the a squared has an area of 1, 2, 3, or 3 squared is equals to 9. And the b squared has an area of 1, 2, 3, 4 equals to c squared that has an area of 1, 2, 3, 4, 5 or 5 squared that is equals to 25. It isn't amazing? Amazing! And this is how Pythagoras' theory proves us. So let's try to apply it. So there's example number 1. As you can see on the board, we have a triangle with two sides already given. One side is 6 units long and the other side is 8 units long. we need to find the length of the third side. To solve this, we'll use the Pythagorean theorem. So, we have to apply the formula a squared plus b squared is equals to c squared. In our example, a is equals to 6 and b is equals to 8. Let's substitute the values into the formula. It written as 6 squared plus 8 squared is equals to c squared. Now, we can calculate the squares. So first, 6 squared is equals to, yes, 36. Plus 8 squared is equals to, yes, 64. So the equation becomes 36 plus 64 is equals to c squared. So adding this together, we can get, yes, we can get 100. Correct. That's right. So the c squared is equals to 100. But we're not yet done. To find the value of c, we need to take the square root of both sides of the equation. So square the c squared and square the 100. The square root of 100 is, yes, 10. The square root of 100 is 10. The length of the missing side, the hypotenuse, is 10 units. We have successfully used the Pythagorean theorem to find the missing side of a right-angled triangle. Do you want another example? If yes, there's more.
That wasn't so bad, was it? Let's try another example. This time, we're looking for a different side. Here's example number 2. This time, we know the hypotenuse is 11. That's right. And one side is 7. Let's use the same formula. A squared plus b squared equals c squared. We know a is 7 and c is 11. So let's substitute the numbers into the formula. 7 squared or 7 times 7 is 49. That's right. And 11 squared or 11 times 11 is 121. That's right. So our equations becomes 49 plus b squared equals 121. Now, we need to rearrange the equation to solve for b. Let's use the subtraction property of equality. We subtract 49 from both sides and we get b squared equals 72. That's right. We're almost there. Now, we need to take the square root of both sides to find the value of b. Using a calculator, we find that the square root of 72 is about, that's right, 8.49. So the missing side is approximately 8.49 units long. Woohoo! You're doing great! Now, let's see how the Pythagorean theorem is used in the real-world applications. Do you have any idea? So first, we have construction and engineering, where they are calculating distances, determining the correct angles for building structures, for building stability. Second, navigation, determining distances and directions, especially in surveying and mapping, like sailors or geodetic engineers, and even everyday life like measuring distances, indirectly solving practical problems involving right-angled triangles can be solved using this powerful theorem. It's everywhere. Do you have any questions? If none, then are you ready to test your skills? Here's a practice exercise. Use what you've learned to find the missing sides of these triangles. Don't forget to check your answers. You got this! Let me know your answers in the comment section. Remember, practice makes perfect. Let me know in the comments if you want to see more examples or have any questions.
I hope that you have learned something today. Let's say, les seamos. We did it!